Stan Forrester, we're back with part 2 of our lesson in 7.6. So let's come on down here. We have a your turn. After we did that last one, let's come on back and let's look at this, look at what that looks like. Okay, so a water tank holds 256 gallons, okay, but it's leaking at a rate of 3 gallons per week. A second water tank holds, well, that many gallons, but it's leaking at a rate of 5 gallons per week. After how many weeks will the amount of water in the two tanks be the same? All right, so we're looking at an initial value plus a rate, except that that rate is actually going to be a subtraction because it's leaking 3 gallons per week or leaking 5 gallons per week. So let's go ahead and let's see what that looks like. Okay, again, we have an initial value plus rate equals an initial value plus rate. All right, and here's the data that we're plugging in. 256 minus 3W. 256 gallons minus 3 gallons per week times the number of weeks. So if after 1 week, you've lost 3 gallons. After 2 weeks, you've lost 6. When W is equal to 2, you've lost 6. And so on and so forth. All right. Here, so we could ask ourselves, well, first of all, we've got the variable on both sides of the equation, and we've got constant terms on both sides of the equation. So let's go ahead, let's combine some terms here. Let's make sure that we end up with a variable term on one side and a constant term on the other. So let's scroll down a little bit. Now, again, we had a little bit of a choice here. So the variable term, I wanted to make sure that that variable term ended up positive. So if I had gone the other direction, I could have just, what we're doing right here is we have minus 5W, and I'm adding its opposite, okay? So this is subtracting 5W. Now I'm doing the opposite. I'm adding 5W. That gets rid of it on this side. And since we do it on one side, we have to do it to the other. So we have a negative 3W plus 5W. Well, if you have 5 of something and you take away 3, you have a positive value. It doesn't take much to figure out that if we'd gone the other route, if we had added 3 times the number of weeks, 3W to each side, well, we would have ended up with a negative coefficient. Remember, these variable terms here are a variable times something called a coefficient. All right. I'm taking a look at this. In the green box, we can see that this is what in the algebra tiles they would have called a zero pair. Over here, we've got to evaluate this. Now, you have 5 of something, and you're going to take away 3 of it. You're going to take away 3 of those. So if you had 5 oranges and someone takes away 3 oranges, well, how many oranges do you have? Yeah, that's right, you've got 2. Okay, you've got 2 oranges. And you can see that down here. You've got this 2 oranges. I've gone ahead and because we have the variable on this side right here, over on the left, I want to try to get rid of the constant on the left, move all the constants over to the right. So this is 256. What do we do to do the opposite? We're going to add its opposite. 256, positive 256. We're going to add negative 256 to both sides. Remember, we do it to one side, we've got to do it to the other. But we do it in such a way that this is what they call the zero pair in the algebra tiles. And suddenly there's no longer going to be a constant term over on the left-hand side. All right. It takes a little bit, 384 minus 256. We're left with 128. So 2W equals 128. So we have a variable term on one side, a constant term on the other. Now we can multiply and divide. Before, well, what we were doing is adding and subtracting. That's combining terms. Okay. Now we're going to use multiplication because W is multiplied by the number 2. So what do we multiply 2 by in order to get, well, what times 2 equals 1? And if you know a little bit about fractions, you'd know that there's something called a reciprocal. 1 over 2 times 2 is 1. Or we could just say we're going to divide by 2. So 2W divided by 2 times the number of weeks equals 128 divided by 2. Well, 2 divided by 2, that's just 1. Okay, and 128 divided by 2? Well, W equals 64. And then, of course, we're going to ask ourselves, does that answer make sense? Does 64 weeks make sense? So we're going to go back to our original equation, and every place where we had that W, we're going to plug in a 64. And I'm confident in this, but I'm going to leave that to you to figure out whether or not this gives you a true statement or not. In example 2, they're asking us to write real-world situations from the equation, not just take a real-world situation and generate an equation, but now we got to go back the other direction. All right, so let's see. 150 plus 25x equals 55x. So what we have is some kind of an initial value, 150, and some kind of a rate, so 25x. And on the other side, we don't have an initial value, but we do have a rate, 55 per whatever's. Okay, and this could be something per hour, or let's say let's say you're having a birthday party and it's $150 for a bunch of kids, and then $25 per kid. Okay, and the other place has just a flat fee of $55 per kid, and you want to see which one of them, for how many kids is the cost equal to each other. All right. And here they've gone down and they've made it a handyman fee. Okay, so yeah, I mean, this example isn't everything you have. It doesn't have to be exactly that. Okay, what they give you an example. Okay, what about this one right here? 30x plus 48, excuse me, 30x equals 48 plus 22x. Okay, for number 3, we've got a new one we have to write a real-world situation for. So 30x equals 48 plus 22x. Okay, so again, on the left-hand side, we've got just a rate with no initial fee, or no initial value. On the right, we have an initial value plus some rate, and we want to know for how many items or how many hours or how many kids these two are going to be equal to each other. So let's just say it's tool rental. Okay, so $30 per hour, or a $48 membership fee plus $22 per hour. And maybe it's even the same store. If you don't have a membership fee, you pay $30 an hour. And if you do have a membership, well, you pay $22, but you have to pay $48 for the membership fee. Okay, so now we're on to our guided practice. We've got two of these. This is x plus 4 equals minus x minus 4, and 2 minus 3x equals negative x minus x. So we're going to come back to our guided practice. Again, here's our first problem. X, just look, see that? There's just a single x there, plus 4. And here's the negative x. Remember, the negative unknowns are still rectangles, but they're red rectangles. And minus 4. Again, we have 4 of the single values right there. And so what can I do with this? Okay, so what is this, which way can I move these variable terms so that I end up with a positive coefficient? This one's already got a positive coefficient. This one over here, I'm going to have to add an x to this side in order to make that go away, and that's going to make this 2x. So let's just go ahead and do that. I'm just going to come in here and I'm going to bring in this value right there. Did I catch that? Yeah, I did. Okay. So I did that. I want to recognize that those two, that makes a zero pair. Oops. I did not do that right. There we go. That just went away. Look at that. So we're now left with 2x plus 4 equals negative 4. Well, exactly how do I get this 2x by itself? How do I get the 2x by itself? Well, I'm going to have to get rid of these 4 here, but there's only one way to do that, and I'm going to have to, one by one, I'm going to have to add a negative value. So each of them just pairs up. But you know something? I can do this really quickly. I'm just going to pair all these up. Now, all of these make these negative pairs. I can just delete that. Okay, these are now negative pairs. Oh, I'm sorry. If I added 4 negative ones here, I've got to add 4 negative units here. All right. But these are now paired up, and I can delete those. Now the question is, now we have, I'll just type that out, we have 2x equals minus 8. Let's see, this is what this represents. This is 2x equals minus 8. That's 2x equals minus 8. So how am I gonna figure out what x is actually equal to? Well, it's actually a little simpler than you might think. I'm gonna move this here, and I'm gonna move this here. So they're kind of separated, and each of those green rectangles is going to get its own fair share of these little red units. Okay, so that x equals negative 4, and that x equals negative 4. And we can always come back here and check that. Put a negative 4 in here. Negative 4 plus 4, well, that's 0. Negative 4, that's like a negative 1 times a negative 4. That's a positive 4. Minus 4, well, that's 0 too. And so that's how we can do that one. Let's see a little further down. How did I... Yeah, algebra tiles number 2. Here's the second problem. Here's our 2 minus 3x equals negative x minus 8. Okay. On this side here, we have those 3 negative x's, and we have the positive 2 units. This is understood to be positive. We have a negative x unit here, and 8 negative units down here. So let's go ahead and let's take care of, which way can I move this so that I'm going to end up with a positive coefficient over here? I think I'm going to end up, if I move all the variable terms over here, I think that's going to do me some good here. So I'm going to, you know something, I think I pre-positioned these here. So I want to move that in there, and I want to take this over here. So if we have negative 3x, if we're taking away 3x, the opposite is we add positive 3x to both sides. It's not going to take much to see that these are all 0 pairs, and those can go away. Well, we don't have 3 0 pairs here, but we do have a single 0 pair. Okay, so we have 2x on this side, minus 8 equals 2. I'm going to go ahead and write that out. I'm just going to write that out so that we can see it, what that looks like. 2 equals 2x minus 8. That's more familiar, and I can get rid of that later if we need to. But let's see, how can I get rid of all of these negative values? I want this term here all by itself, this 2x term by itself. Well, let's come back up here. There's 4 of those, so I'm going to grab 4 of these. Oops, I grabbed too many of them. I'm going to select, I'm going to grab 4 of these. I'm going to add it to that side. Add it to that side. So it's very explicit that these units are all pairing up with each other. Now I added 8 of these on this side, so I've got to add 8 over here. 2 groups of 4. All right, we can take a look at this. We can see that those go away. Okay, and this no longer describes the situation we have, so I'm going to get rid of that. And this is now 2x equals 10. 2x equals 10. So how do I get what one of these is? I'm going to separate these out, and I want to make sure that each of those green blocks gets its fair share. Of yellow units. Okay, so 1, 2, 3, 4, 5, 1, 2, 3, 4, and we can see that x is equal to 5. You can plug that in if you want. 5 times negative 3 is minus 15. Okay, negative 5 minus 8 is negative 13. Yeah, it seems to work. And we're back to Go Math. I want you to go ahead and take and pause this for a moment before you go to part 3. And I want you to fill in the pages that we've already covered. We've covered the beginning of 7.1 all the way through problems 1 and 2 on the Explorer. And in the next video, we're going to cover the rest of this page.